one, you have to know that this triangle is equilateral. But does that help you solve the question? Right, so knowing it's equilateral helps you understand that it is equiangular. Does that help you solve this problem? Why?
Because all equiangular triangles have all three of the angles are 60 degrees.
Perfect. So if it is equilateral, you should be able to justify that it's equiangular. And if it is equiangular, that means that all the angles are 60 degrees. So if all the angles are 60 degrees, you can write that in the triangle: 60, 60, and 60. Now, do you have to do all those other steps that I did to solve this problem? Not necessarily, but it's good to know where all the information is coming from. So, how do you solve for x now? This is where I'm going to stop. And you will keep going when it's your time. Right? So that is the key to unlocking this question, that 5x plus 15 is equal to 60 degrees. That's how you get credit for the question. The only part that you can screw up is solving it incorrectly. And that's the part that you have to do by yourself. Okay? So this is how it's going to look today. We're discussing it was equilateral, so it can be equiangular, so all the angles are 60 degrees. That is how I generate this equation. But what about number 2?
It's isosceles.
So you have to know it's isosceles. But how do you know it's isosceles?
Because it has two congruent base,
Because it has two congruent base
or
angles. Does knowing that it's isosceles with two congruent base angles help you solve the problem? Not really. Because are there any angle measurements listed there? No. But
it has two congruent legs.
because it's isosceles and it has two congruent base angles, you know that these legs are equal to each other. Now, could you have guessed on that problem and said 22 equals 8x minus 10? Yes, you could have guessed and got it correct. But that's where I'm going to stop. You have to solve this by yourself to get the x equals answer. Cool? Is this too slow? Or is this good information? I think it's great information. Like I said, these are going to take us a little bit of time today. Alright, now for this question it says we have two congruent figures. We have figure ABCD and we have figure EFGH. It wants you to solve for x. So what is the hard part about this problem? Everything. Go ahead, Colby. No, you already raised your hand. Can't take it back.
You have to read the question.
You have to read the question. So why does reading the question help you?
Then you know that they are congruent.
Yes. So does that mean that angle B and angle H are the same?
Yeah.
No, it doesn't. We have to read the congruency statement. It goes A, B, C, D. It goes like that. The other one goes E, F, G, H. So we have to find the parts that match. And I like to do it with the congruency statement.
Oh, I know.
Smart, right? So that one little trick of writing the congruency statement. So you see how AD has 6x minus 12 next to it? Yeah? I see it. Do you see it? So AD, this part right here, has 6x minus 12. So that is A and D. That's the first letter and the last letter. Its corresponding part should be EH. You see EH has 3x plus 9 right here? So those two things should be equal. Now, if you didn't go through that whole process, could you have guessed that those two things are equal to each other? Yeah. Okay, so that's why it works, but that's the problem that you have to solve. Right? The second one's a little bit weirder. It says solve for y. So where is angle y?
G.
At G. It's right here. So G is the third letter in the statement. What is the other third letter in the statement?
C.
C. So you should be able to conclude that G and C are exactly the same size. So G is 8x, 8y plus 39. And C is how big? So those are the two expressions I'm asking you to go back and solve later to really get the x and y values. Was that bad? Did I make it harder than it was? I probably took a lot longer for me to do it than for you to do it by yourself. Okay. How would you explain this to somebody? Like not in Baker speak.
Two base angles.
No, if you were just telling this like, hey bro, here's the answer real quick, how would you tell him?
4x plus 20 equals 84.
So you would say this, right? And you're absolutely correct. But I can make you go through the process of saying it is an isosceles triangle. And because it is an isosceles triangle, this side and this side are equal to each other. And because those sides are equal, you can set those expressions equal to themselves. It kind of makes sense? So I can drag it out and make it terrible, or I can do it real quick and you can just kind of guess at what the answer is. Alright, ooh. Alright, this is the first question on the test. This is the first question on the test. Let's see how good or bad I did at teaching this.
Okay. Aren't supposed both of them supposed to add up?
Do what?
They're all just straight lines, so couldn't they?
Okay, so understanding that 3x minus 1 is right here.
Yes.
And 4x minus 1 is right here. This is weird, isn't it? So here's how I attack this problem. This is an isosceles triangle. Y'all see that?
Yes.
Because that it is an isosceles triangle, what do you know about isosceles triangles? Base angles are equal. So if this angle is 3x plus minus 1, how big is this angle? 3x minus 1. So now I have a line that looks like this with a 3x minus 1 angle and a 4x minus 1 angle. So the hard part is saying that these two things should add up to how many degrees? 180. So 3x minus 1 and 4x minus 1 add up to 180. That problem is significantly more difficult than your test because the way it's represented. On your test, it looks like this. Is that easier to recognize?
Yes.
This is an isosceles triangle, so if this angle is x big, how big is this angle? X. So these two things add up to
180.
That's how it looks on your test. The only bad part about the test is it's a decimal answer. But it's multiple choice. So kind of a trade-off. So if you know you get a decimal, don't freak out. So you guys can go back and solve this one. And I'll get you where you need to be. Alright. Now I don't know how you live your life here, so I'm trying to kind of take what you give me. What kind of triangle life do you live?
3x equals 60.
Okay, so I'm gonna hold you right there. So Jordan says, does anybody not understand that? Everybody gets it? Okay, so if you don't understand this, I would recommend saying, what shape is that? How many degrees are the triangle?
180.
So 60 and 60 and 3x add up to 180. That's an easy way to make that just a triangle problem. What Jordan did was he recognized that it was a 60, 60, 60 triangle. So he went ahead and solved for the missing angle and said 60 and 60 are 120. 180 minus 120 makes this angle 60 degrees. So he went ahead and solved for just the angle and got 60 and then set those two things equal to each other. Lots of different ways to do it. One might be a little harder to solve. One might be a little easier to solve. Okay, it's harder to get here. It's easier to generate this one. It's harder to solve that one. It's easier. So it's kind of a tug of war there. All right, let's try another one. You want to do it that way? So go back to the kind of the easy math. This angle plus this angle plus this angle all adds up to 180. Here's what I did. I went ahead and added these two together, and I got 150. And I said 180 minus 150 is 30. So I know that this angle is how big. Then I said that 30 equals 6x. They're still both the exact same equation. One is easier to set up, one is easier to solve. They still generate the same answer of 5. Are you feeling confidence? Lack of confidence? Love it? Love me? Bless you? Alright, this one's kind of a weird one too. There's about 8 different ways to do this. You want the easy, medium, hard, or impossible way? The easy way? The easy way says all of those angles add up to 180. How big is that?
90.
Just checking. Very repetitive mathematics here, right?
Yeah.
Now, how do y'all feel about that equation?
Easy.
I think it's icky.
Stretches
So you
more.
combine the like
Yeah, that's a lot of work though, isn't it? So if this is 90, then what do these two have to add up to? If this is 90, I don't want to talk about this one. How many degrees left over for these two?
90.
90. So you could say that the other two angles, right? But that's kind of confusing, isn't it? That these two angles add up to 90. Does anybody like that one? I did this. I said 90 plus 52 is 142. So then this angle has to be 38. I went ahead and gave it a numerical value. So it's easier for me to solve that one. That one seems easier to solve to me, but you have to do a little bit of mental math or preliminary math to get there. Like it or don't like it? Right? Doesn't matter, it's worth points tomorrow. Alright, last triangle. Save the hardest one for last. This angle is 30. So how many degrees does that angle on the inside and that angle on the outside have to add up to?
180.
180. So 30 plus x equals 180. This is kind of a distractor. Alright. We're at the top of the mountain. We just did Miley Cyrus to climb. What's up?
You subtract 30 from both sides.
Yeah, so that's for you, alright? I'm not going to solve it today. I want you to practice that. So we're at the top of the mountain. That was like half of the review. Miley Cyrus, the climb is over. Now we're downhill for the rest of the review. We've done this over and over and over again in class. It says, can you write a congruent statement? This was that true and false question yesterday on the quizzes. Remember that one? So it gives you QRS and it wants you to write what it's congruent to. So QRS goes like this. Oops. QRS, that goes from the 2 to the 1 to the 3 marks. So how do you have to write the next statement? That is the only way to mark it. The order really matters there. So I'll let you guys try number 6 by yourselves. That way you can have a little bit of independent practice on that one. Alright, just like your problems yesterday, all 43 of them. It says, which shortcut proves that these two figures are congruent? What about number 1? What does that look like to you? Huh? Anybody? So this is important right here.
HL.
Now look, do you see this mark right here?
Yes.
And what else can you conclude because you're an amazing student?
The middle line is congruent.
So what shortcut is that?
HL.
That is not ASS. Is that even an option up here? No. Never select ASS. Ever. So if it's not ASS, it has to be HL. It's the hypotenuse leg. Yes.
So, right, like if that were to be on our test and it didn't come out to be
So are right, I think the question is, are right triangles always HL?
No.
Is that, I think, so what if it looked
Yeah.
like this? What shortcut is that? This is actually side, angle, side.
So if it doesn't spell out like a congruent shortcut, then it's not.
Yeah, if it spells out this,
Then it's
and there
HL.
is no, if it looks like this, we're talking about this question right here. What is the shortcut? HL. Is that this?
No.
Is that this?
No.
Is that this?
No.
So you say, is that kind of cleared up a little bit? Can you guys want to try 2 and 3 by yourselves, or do you want to go over those?
Go for that.
Number 2. So what do you think number 2 is? Yeah, 4 options. If you don't, you can mark it. This is a side. This is a side. This is an angle. This is an angle. Now here's the problem. Look at those letters. What do you have 2 of? You have 2 A's. And most of you guys are trying to determine which one of those 2 it is. Is it ASA or is it AAS? Is the S between the A's? No. So what shortcut is it? It's the AAS shortcut. Was that a good little tidbit there?
Yeah, easy those.
What about number 3?
It is the SAS.
Okay, if you see this side is congruent to this side, and this angle is congruent to this angle, and this side is congruent to that side. Is that ASS? Is that SAS? That's the SAS, because if I trace down this side and I trace down this side, where is that A? It's between the two S's. That becomes the SAS shortcut. Alright, I'm going to let you guys try this matching section by yourself. It is matching. So 1 for 1. You cannot reuse the letters. Number 6. No. It's just a bad question. If you want to do that one by yourself, go for it. If you want to skip it, you have my blessing. Try it by yourself. I'll even give you the answer. This is the correct answer.
Yeah.
Let's go.
Let's go.
Okay, that is the correct answer, and you can figure out why that's the correct answer later if you want to. All right. This section, you kind of have to read the directions a little bit. It says, decide whether the triangles can be proven congruent by the given postulate. Are these two triangles congruent by the HL shortcut?
No.
No.
Yes.
Yes.
No.
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 Shut up and give me the answer, right? So if you say no, why no?
Because there's like a hypotenuse and leg, and they're both the same. On
Did
both.
you said yes then?
Yes.
You said yes, I said no.
You said no, why no?
I said no because there is no given 90 degree.
Are they right triangles?
Yes.
Where?
It's like on the angle.
Where's
Like
where's the box?
That could be 90.
It could be
like
91
it
degrees.
could be like,
So this is no. And it's like a no, because they look like they're right angles, but they are not right angles unless they are listed as right angles. So you have to see the box there for it to be a right triangle. If there is no box there, you cannot create one for yourself. Number 14. Are those two triangles congruent by the SSS shortcut?
No.
No. Any problems with that one? That is obviously not SSS. Okay, here is where you get to add information without any mathematical justification. It says for number 7, make them congruent by the HL shortcut. Make it happen. Are they right triangles? Yes. They already have one thing marked congruent. What is the one thing marked congruent? The L's are congruent, right? So what do we need to be congruent for the HL shortcut? Hypotenuse. So you have to mark these two pieces. Now they're congruent by the HL shortcut. Number 8, this is kind of I'm not a huge fan of this question because it can be confusing for people, but we're going to give it a shot because we're smart. Make those two triangles congruent by the AAS shortcut. So right now we have an A congruent to an A. We have another A congruent to another A. But we need an S somewhere. You want to say this one? And?
If.
Is that the only answer?
No.
No. You could have picked A, B, and D, E. But you cannot pick that piece. If you pick that one, you're wrong. Then it would be the ASA shortcut. Like I said, it's a whatever question. It says, tell me how these two triangles are congruent. Another beating you over the head with this. Can y'all kind of take care of that one by yourself? Or do you do it together? Okay, so how do you think that these two are congruent?
A side equals side.
This is a side marked congruent to this side. This is an angle marked congruent to this angle. And then that one hidden piece right here, this side is congruent to itself. So as you trace the information side, what shortcut do you have? What about number 10? Number 10 is the HL shortcut because they are right triangles. Okay. Allow me to just veer off the review path for just a second. 2 years ago, or last year, the test looked like this. This was the test question. Yikes, right? Completely blank. So last year I changed it to this. Still not very successful. So this year I changed it to this. This is the new version. This is how your test looks now. You have to fill in the last two blanks. So everything is there for you. You just gotta fill in the blanks for yourself. Right? I think that's a good compromise to maybe get a little bit of student input out of this one. So, what do you think would be the most intelligent way to start this one?
Start marking stuff.
Marking stuff is huge. So angle K and angle N are the same. That's good to know. Angle KML, that goes like this, KML, that's this angle right here, is congruent to angle NML, that's this angle right here. And then I'm telling you, the test told you that LM is congruent to LM, so you want to mark that as well. And you have to know why that's true. The whisper reflexive property. So you guys need to know that for tomorrow, because that will happen tomorrow, the reflexive property. And then you have to generate what shortcut proves that those two triangles are congruent. The AS shortcut, the angle, side shortcut. Was it that bad? No? Do you want to go a little extra and try and do the whole proof on the next one? Or should I go ahead and
I got you.
So they already have marked that this side and this side are congruent, and this side and this side are congruent. What do you think the next thing we should say is?
QN is congruent to QN.
What's that? Is that their arrows again? Is that a parallelogram? So again, the test will give you that. Why is QN congruent to QN? Reflexive. Like you're flexing your brain on this test, the reflexive property, LEX. So then you're here at the proof step. And why are those two triangles congruent? So, again, like I did a lot of this with you, but there's a lot of questions we skipped over for you to practice individually. Tomorrow is just test time. Cool? And then let me kill this recording real quick.